Okay. Hopefully, y'all still here? I don't know if the URL changes. Not like if y'all go straight, I can't see anymore. Um, uh, Regardless, we still have a good like hour left. So if everybody left the stream, that's okay. Y'all can watch it later. I'll make sure to send an email and let y'all know in River as well. I'll go ahead and finish the lecture. In the future, honestly, this is kind of pain in the ass. Chris is here. This is kind of a pain. So if it seems like the bandwidth is super high. The reason I've been doing these YouTube streams instead of Blackboard is to preserve y'all's bandwidth, but if it's just like messing up, then I may just do it on Blackboard anyway. Um, I'll take a look at the analytics afterwards. Uh, okay, so we uh, we left off before I was having an issue. Everybody can see the screen now, right? Let me ask in chat. Uh, cool. Okay, we can see the screen. Uh, before we had to fix the screen situation, what we were talking about is that like this doesn't fundamentally solve the issue of not wanting to copy and paste our code over and over again. We have our car here. We want to make it so that this recipe is essentially really flexible. So right now, if we go back to that cake or pizza metaphor, there's a bunch of different kinds of cake we could make. We could make a chocolate cake. We could make a vanilla cake. We could make a devil's food cake. We could make an angel food cake. We could make a red velvet cake. They all have similar steps, but they're slightly different. We could, in this situation, we want to make a blue car on the left side of the screen and a red car on the right side of the screen. The steps are kind of similar, but there are small variations, like the exact position and the color. You might think off the top of the bat that we want to like copy this and paste this and then say make car 2 and then start changing these numbers. No, we don't want to do that. Do not do this. That defeats the purpose of functions. In that case, I would just copy and paste all this code and put it inside a draw. We want to use only one function. To draw multiple cars. Cats. Cats would be cooler, but I mean cars. So we do not want to do this. That is bad. And don't do it on your homework, because I'm explicitly telling you right now, your homework is not going to be to like make a bunch of cars with a bunch of functions. You're only going to use one function. So what we need to use are parameters or arguments. In the functions we've been using in the past, they've had parameters. So when we say rect, to draw a rectangle, we always give it 4 numbers. These 4 numbers display the x, the y, the width, and the height of our rectangle. We want it to make it so we can do the same thing for our car function. So we have to do a couple of things to the way we wrote out our instructions, wrote out our first recipe card. And that's to deal with stuff here in the parentheses. This is where we put, like, this is similar to declaring a variable. It's like we're declaring our parameters. So we want our cars to be able to be in different positions and in different colors. So we have to turn the values for our colors and the values for our positions into arguments, into these variables. So I'll say float x start, float y start, float red, float green, and float blue. A couple of things happened when I added these. So first, my make car function just got a bunch of red squigglies underneath. It says in the bottom in this red area, that's where it describes your error. It says the function make car expects parameters like make car float 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 float. That means it needs 5 numbers, right? It can't run unless I put 5 numbers into these parentheses, similar to if I tried to use rect without any numbers. You would get like the exact same error. Because now I have to start giving it these parameters. Before we get to that though, what's this other error? It's like this yellow squiggly line, which we haven't really seen before. This yellow squiggly line is a warning. It's not an error. Our code would still run despite these warnings, but it's trying to tell us that here we can see it says the value of the parameter xstart is not used. What that means is we like declared this parameter, but we never actually used it at any point. We just like set it up. We told the computer to set up that box to store a value, but then we never actually used the box. We never referenced that number. That is going to go down here in our code. This is the part where we're going to have to go back to doing a little bit of annoying math of like figuring out where things are on the grid, because everything is going to be in reference to these two points, this x and y position. So this is like our starting rectangle. We'll call it our reference rectangle. All other shapes are drawn in reference to it. So its x position for this rectangle, I think it's the start of the car, the little front part, is going to be just x start, this variable, this parameter. You can see now that x start here, the scary yellow squiggly line is gone. So now we just need to change the rest of these to be used. So the reference rectangle is also going to have its y start be that y position, the parameter that we're plugging in. Then what's going to happen is that the rest of our car, the body and the tail, are going to be like x start plus some value. So in our original code, we started x at what, 80? And then the body of our car was 60. So if the hood of our car started at 80, the body of our car started at 60, that means the body is 80 pixels over from the start of the front of the car. So I'll say x starts, which is where our hood starts, plus 80. Same thing for the tail, just a little bit of math. So our hood is starting at 80, our tail starts at 280, which means our tail x position is 200, is over 200. So it'll be x starts plus 200. Okay? Stay with me. So then our circles, it's a little bit more math. So we started at 80. The first tire starts at 130, so it's going to be x start plus 50. And same thing for our right wheel. So it'll be x start plus 220. It's over 220 from 80. And we'll do the same thing with the y. So for our body, y position starts at 130. The 130 position our hood started at is 180. So let's see, 130 minus 180. So it's a difference of 50. So it's going to be y start minus 50. We're going up. If this is like kind of like blowing your mind a little bit doing this math, you're like, how, like, I don't understand. Keep that in your mind to bring up and ask either during office hours or during review and Blackboard at the start of next week. Then we can visualize it on a grid. All I'm doing is seeing where the other shapes go in relation to our first little shape. We can draw it out on the whiteboard like we did with the car stuff this morning. So I'm going to do the same thing with the hood of my car. In this case, it's actually the same position. So the tail of my car is at the same Y position as the hood of my car, so it's just Y start. It's the exact same. Then I go down into the circles. So my Y start again, it was 180, and my tires are drawn at 230, so 230 minus 180 is 50. So it's going to be y start plus 50. So it's 50 down from our reference y position. I know, again, it sounds like a whole lot. Like, what am I even talking about? It'll take some time. This is why I've been having you just draw stuff in processing. It'll take some time to wrap our heads around it. The key idea here is that we have the hood of our car, and it's like we're finding where the body, the tail, and the two wheels are in relation to that. Okay? Then the last parameters that we haven't used yet, the red, the green, and the blue. Those are going to go inside of our fill. So I can say red, green, blue. And then once again, those scary yellow squiggly lines underneath our parameters have disappeared. So now let's go ahead and take care of this scary red squiggly line. Now we're actually going to give it the values that it needs. So we give it the X and Y position. This is, again, the reference point for everything else. It's where we're kind of starting our drawing. So we'll say, what did we say? Like 80, 180. It's the X and the Y, and then the red value, we want it to be a red car, so 255. The blue value, or the green value, so 0. We don't want it to be green at all, and then 0, because we don't want it to be blue at all. Okay? These numbers are parameters. This is just like what we do with ellipses and with circles. We're just giving it its starting position, and then the color we want it to be. The only difference is that we wrote it. We did it. We can make it however we want. So when I press play, I get the exact same thing I've had this whole time. The difference is, I now don't have to fiddle around with messing in any of this code. This code is done. This make car stuff. I can now change the position of my car simply by altering these numbers. So maybe I want it to start at 0. If I want it to start at 0, I change the first parameter, which is my starting X position, to 0. And now my car is over on the left side of the screen. If I want it to be like halfway through, like you only see the tail end of the car, I could make it negative, let's do negative 40, 440. And now it's like I can only kind of see it. It's gone a little bit. Let's make it 80, and then we can also change the Y position to 280. Let's make it a blue car. So make it blue instead. Actually, let's make it a purple car. So red and blue. So now we have a purple car that's a little bit lower to the right. All I'm editing are my parameters here in make car. This is like we're changing some key ingredients. The core idea of making a chocolate cake versus a vanilla cake is like the same steps. The only difference is that in one I'm using vanilla and in one I'm using chocolate. In this case, the steps to make a car are the same. The only difference is where I'm drawing the car and what color the car is going to be. I think the biggest problem here, probably the biggest thing that seems scary and frustrating, is the math stuff of positioning things. This may be a helpful time to use one of those graphing tools that you can find online to help you visualize it. But I really, really want to stress that all of this is just moving shapes on the grid. All of this, like adding 80 and subtracting 50. I'm just taking a look at what my original starting positions were. This is my code from when we were not using parameters. And I just used this and like did some math. So if this is my starting position, I want the first rectangle to be my starting position. Then I see what the difference is between all of the other XY positions here. Can you set it so it chooses between a range of numbers so you don't have to change it every time you want a car in a different spot? Like just so that it's random? In fact, we can do random. That's another function. That's a good thing to learn just for now, just a quick detour. I could say random, and then I could do 0, 100, or no, what's the width? 0, 500. 5,000. And then I could do random 0, 500. So every time I run my code, it's gonna randomly choose a spot for my car. So let me press play. And so, like, every frame, it's like a different position. I don't know if this is showing up properly in stream because it's so fast, but it's basically just moving every frame, just all over the place. So we have a random position every single frame. Yeah, so that's how you do some RNG stuff. Literally just random. You can see that it changed blue. That means it's a built-in variable that built-in function that processing has. It takes two parameters, which is like the minimum and the maximum. So you want a number somewhere in between these two. So that's how you could do like an RNG situation, so you don't have to change it every time. So we now have everything we need to just start drawing a bunch of cars on this screen. We can keep using our function. Make car, let's do 0, 400, and I'm just going to do some random colors here. Let's do 20, 67, 149. Make car, let's do 300, 450, 201, 3, and 87. So I'll press play, and I now have 3 different cars and 3 different colors at 3 different positions. So I have this recipe, and I can make as many cars as I want. They can just go all over the screen. This is really, really like a very flexible and good tool to use, especially in something like a game where you're doing similar things over and over again. Like if I'm trying to recreate Mario inside of processing, I'm probably gonna have a bunch of Goombas, and I need all of my Goombas to look the same, and they all kind of act the same. So I would probably have a function that determines my Goomba's behavior. If I am making Pong, the 2 paddles on the side of the screen behave in similar ways, right? They all just go up and down, and they're able to bounce a ball back and forth. The only difference between the two is where they are on the screen, where the 2 paddles are located, and what keys you use to control the 2 paddles. You're either using the up and down arrows, or you're using W and S maybe. So I have a function that gives me the movement of my paddles, and it takes parameters of what keys to use. Parameters can be anything. It helps us, again, create code that we want to use over and over again with slight differences. So the inside, all of this stuff should be familiar. We're just using this code, these parameters, these arguments, to change small parts of the code. And we're using it in a way similar to variables. And I want to point out that this is another situation where we need to talk about scope. So I told you that scope in programming, when it comes to the scope of a variable, is referring to, again, if I'm talking about like the scope on a gun in a first-person shooter, I'm either zooming in or out. So these parameters are like variables that are very, very zoomed in. These parameters can only be used inside of make car. I cannot say inside of draw x start equals 0. I'm going to get that scary red squiggle because x start does not exist outside of make car. Its scope is only inside of make car. It's like a variable that only belongs to it. So I can't change it elsewhere. If I wanted to make it so that my cars moved, I would have to add those variables elsewhere. Like I wouldn't want to be doing that inside of make car. We don't want to worry too much about the animation stuff for this week. We're not going to worry about the conditionals. We're really trying to wrap our heads around this function stuff. So hopefully we kind of understand it. Functions give us the ability to reuse code with small differences between each time we use it. So let's talk about the homework for next week. Let me go ahead and open up River. Where is that? It's over here. Okay. So your homework that's due next week is to make a city. You're going to do a city recreation. You can try to make the city around you. You can just make a generic city, whatever. You could just make a little village. It's up to you. You need to have a function that is drawing two functions that draw different kinds of buildings. So you can have one function that draws a house and one function that draws a skyscraper. The two functions have to have two parameters that alter the look of the buildings. So you actually probably want multiple parameters if you want to get really fancy. But at the bare minimum, your two functions, your draw house and draw skyscraper functions, are going to have an x position and a y position parameter. So two functions with two parameters that draw two different kinds of buildings. And then you need to make three buildings each with these two functions. So you'll have 6 buildings total. 6 buildings, 3 of each type, so 3 skyscrapers, 3 houses, made from 2 separate functions. In your homework, what I don't want to see is for you to have 6 functions that are like void draw house 1, void draw house 2, void draw house 3, void draw house, or not draw house, draw skyscraper 1, void draw skyscraper 2, void draw skyscraper 3. Do not do this. This is not proper use of functions. This defeats the purpose of functions. You will only have 2 functions. Draw house and draw skyscraper, or whatever kind of buildings you're drawing. Then they'll probably take 2 variables like float x, float y, float x, float y, and you'll call them inside of draw like draw house 10, 100, draw house at a different position, so like 200, 0 maybe, draw house 300, 24. It doesn't like that I didn't have my capitalizations matching. And then inside of draw house is the code, the directions, the steps of the recipe of drawing a house. Okay? There's also, I want to point out, extra credit for this. So you could create another function, it says second, I should change it to third, that draws something else in your village. So you could have a third function that draws trees or people. You could have a function that draws a road, or you could have a function that draws a car. If you have a third function that draws something else in your village, I will give you 3 points extra on your homework. And then we didn't have a devlog this past week, but we do have one for this week where you're going to write about what you think functions are for in games, and think about times in your previous homework where it would have been helpful to use a function instead of just repeating code over and over again. If you're not sure about this homework, if you have questions about what is going on with it, ask me right now. Either ask me in River in the chat or send me an email if you're unsure about something. Then, if you're working on your homework and you're confused and you need help, come to office hours. Please come to office hours. I want to see people in office hours. Or go and see the tutor. Also totally valid, a really great option. So that's it for this week. We did some review, we learned about some functions, and I will see you next week with all of your beautiful villages made from functions. See you later.